Hi folks! Today we're going to take a look at the Chapter 3 practice assignment, which is actually just a lightly adapted version of the test from 2020. So the first question says, what's the remainder when this is divided by this binomial? There are a few ways you could do this, but probably the slickest is to use the remainder theorem, which says just plug in the number -3, the number that would zero out this binomial, into the polynomial. Okay. And we can go through an alternate technique in just a second here. So I'm going to write it out, and I'm going to evaluate it. -3 to the 4 is 81, minus -3 squared is 9, minus 6, and sorry, that should be a minus 1. Minus 1, that's 81 minus 16. There we go, gives us 65. If I didn't get one of these three answers, then I'd probably go back and check whether I'd goofed, and that's what would happen if I had got the +1 over there. Another way that you can approach this is to do it by synthetic division. So you'd put a -3 here and plus and times. The only thing to watch out for is that this polynomial doesn't have an x cubed term, so it needs a placeholder for its x cubed terms. And then we just go through the process. Bring it down, multiply, add them up. Multiply, add them up. Multiply, add them up. Multiply, and 66 plus -1 is 65. So either way, we're getting 65 as our remainder. The next one asks, what's the factor of this whole thing? Now, a keen eye would notice here that these are all pluses or positive terms, so the only way you're going to get 0 is by subbing in a negative number. And you'll only sub in a negative number if you have an x plus 1 binomial. That's not really a good explanation of why it's true, though, so maybe we should actually plug it in and make sure it's going to work. So if I put in -1, I'm going to get -1 to the 4 plus 10 times -1 cubed plus 3 times -1 squared plus 50 times -1 plus 24. Okay, let me work this out. So that is 1 minus 10 plus 35 minus 50 plus 24. And what I always do is just say, how much do I have in the positive direction and how much do I have in the negative direction? I have 60 positive, 60 negative. That gives me 0. So I must have found a factor at x plus 1. The maximum number of x-intercepts on a cubic. Let's think about that. A cubic can do this kind of thing. So the biggest number we could have is 3. The number of y-intercepts on a quadratic. This is kind of sneaky. If I draw any quadratic, indeed, if I draw any function, the maximum number of y-intercepts you can have is going to be 1. And every quadratic polynomial is going to have one y-intercept. It's going to cross the y-axis one time. And if you try and get 2 y-intercepts, well, that means that you no longer have a function. All right, consider the graph below. Is the leading coefficient positive or negative? Is the degree even or odd? So we could do our dance, but the basic look of this graph is doing this kind of thing, down to down. Okay. So that would be a negative even degree polynomial. The equation below takes the form x cubed minus 2x squared minus x plus k. And k just means the y-intercept. So k is going to be equal to 2. When you have expanded form, that constant is just the y-intercept. There are other more complicated ways to figure that out, but that's the slickest. All right, on to the questions where we need to show some work. So we can divide here. We state the restrictions on x and write our answer clearly. I'll do it both ways, but you just have to do it one way. So if I do it through long division, I'd have 2x cubed minus x squared, okay, plus 0x plus 4, all divided by x minus 2. Okay. And I'd divide 2x cubed by x, gives me 2x squared. I'd multiply through 2x cubed minus 4x squared, and I'd subtract the whole thing. That's going to give me 3x squared plus 0x, and again, I'll divide. 3x squared divided by x is 3x, and that'll give me 3x squared minus 6x. And again, I subtract. That gives me 6x plus 4. This question is not asking us to factor. It doesn't necessarily have a remainder of 0. So 6x divided by x is 6. That gives us 6x minus 12 with a remainder of 16. So the way we should write the answer in the end is that we have this plus 16 over x minus 2. And the restriction on x, you can see it right here. X can't be 2 because you can't divide by 0. Now, if I did that with long division, I'd probably want to check with the remainder theorem to make sure that my remainder is correct, and that means I'm probably okay. Or we could just do synthetic division to check. The only thing with synthetic division is you have to be really careful about that placeholder. So there's 2x cubes, there's minus x squareds, there's 0 x's, and there's 4 just regular constants or units. Okay? And because it's x minus 2, we put a 2 over here. And we pull it down, and then we multiply. And we add, and we multiply. We add, and we multiply, and we get the same result. You have to write what this means, though. You can't just leave it as 2, 3, 6, 16. That's just numbers. Okay? The result is that you get this polynomial with this bit of leftovers. And again, x can't be 2. Next one says, if x minus 2 is a factor of this, find the value of p. Well, if x minus 2 is a factor, we'd put in 2 for x. And if it's a factor, then we would get 0. So that's what it's telling us. If you put in 2 to this function, then you should get 0. Put in 2 for x. So let's do that. 2 cubed plus 3 times 2 squared plus p times 2 minus 8. If we do that, we should get 0. And so that's 8 plus 12 plus 2p minus 8 equals 0, or 12 plus 2p equals 0. Now this is not a quadratic, so at this point anyways, so we want to get our letters on one side and our numbers on the other. So we get p is negative 6 as a final answer. All right, the next one, the biggie. Factor this completely. So we know that our possibilities for things we can check are plus or minus 1, plus or minus 2, plus or minus 3. I mean, I could stop listing them because I'm probably not going to check all of these. I'm just going to check until I find one. Easiest thing to put in is 1. So if I put in 1, it'll just be the coefficients. 1 minus 6 plus 9 plus 4 minus 12. Oh, this looks kind of promising. Let's see. That would be how much positive? 14. How much negative? 18. It's not equal to 0. We didn't find a factor. So we'll just try something else. Put in negative 1. Get negative 1 to the 4 minus 6 by negative 1 cubed plus 9 times negative 1 squared plus 4 times negative 1 minus 12. And it turns out that is going to give us 0. And once we figure that out, then we want to divide. What we found here is that x plus 1 is a factor. And I'll always write that so I'm clear. What have I found? And once we've found that factor, we're going to divide. I don't know why I'm getting this arrow here. There we go. And I'm going to do it synthetically. Wow, amazing. The iPad will straighten out that curvy a line. Here we go. Coefficients 1, negative 6, 9, 4, negative 12. A question like this should be taking us, like 5 to 7 minutes. We'll multiply, we'll add 16, multiply, add, oh my gosh, remainder of 0, just like we expected. So that means this whole polynomial to begin with, it can be written as x plus 1 by x cubed minus 7x squared plus 16x minus 12. No leftovers. There we go. Okay, and now we need to find factors for this one. So I could try -1 again. I don't think it's going to work. So the next thing I'll try is 2. There's no point in trying 1. If it didn't work in the original form, it won't work later on. So I'll try p at 2 in this one. That'll give me 2 cubed is 8. Okay. Minus 7 times 2 squared, so that's 7 times 4. Okay. Plus 16 times 2, that's 32. Minus 12. Positive 40, negative 40 equals 0. X minus 2 is a factor. Optional, exclamation mark. Yeah, okay. And we just do the same thing. We're going to put a 2 here, because that was the number. The binomial was x minus 2. And we have coefficients of 1, negative 7, 16, and negative 12. Now, this might be clearer what we're doing if we did long division, but it would take a long time. So if you're having trouble with this process, section 3.3 is all about that, and there's a video lesson for section 3.3. All right, multiply and add and multiply and add and multiply and add. So that means that the polynomial is x plus 1 by x minus 2 by x squared minus 5x plus 6. And that quadratic, we can just factor as a quadratic. It's a short trinomial, so what adds to negative 5 multiplies to 6, negative 2 and negative 3. Great. And because it contains a doubled root, we should write it this way. X minus 2 all squared by x minus 3. There, it's all factored. Now we're asked to solve for x. What if that polynomial was equal to 0? Well, we just showed that that polynomial factors like this. So what numbers are going to balance out this equation? Well, if the first bracket were 0, that means x was negative 1, then the whole thing would be 0. If the next bracket was 0, meaning x is 2, then the whole thing would be 0. Or if x was 3. Okay. These correspond to the x-intercepts on the graph, but here we're just thinking in a single variable. And since we've got it factored and equal to 0, it's just whatever makes each of those brackets 0. That brings us to the graphs. So sketch a graph of each of the following. These are all already factored for us. So let's see. The degree here is going to be x times x times x. So degree is 3. Degree is odd. And it's got a negative leading coefficient. So in terms of a general look, it's going from up to down. Next thing I want to find is maybe my y-intercept, because it's fairly easy. So y-intercept, we sub 0 for x. So that would be y equals negative 2 times 0 plus 1 by 0 minus 1 by 0 minus 4. Or, let's see, we've got 3 negatives there, so it'll be negative. So that'll give us negative 8. The next thing we want to do is talk about the x-intercepts. And they're actually really easy because it's already factored for us. The x-intercepts from this one are negative 1. This one are 1. And this one is 4. And there's nothing special about any of those. They don't have a bounce. They don't have multiplicity on them. They're just a regular bracket, x plus 1 and x minus 1 and x minus 4. So let's put on some points. These are the points. I know. Okay. And I know it has to come from up top, and it has to thread through these x-intercepts, and then go downward like this. For full marks, I need to show that that y-intercept is negative 8. And there you go. There's the graph. The next one has some multiplicity on its roots. So let's see. Essentially, it's an x times an x squared times an x cubed. Its degree is 6, which is even. And there's no leading coefficient out front, so it's like there's a secret 1 here. So it's got a positive leading coefficient, meaning that its general look, degree is even, is something like this. Okay. I'm going to get rid of some of these extra scribbles here and get down to business. Maybe this time I'll find the x-intercepts first, because they're right there. So this is definitely an x-intercept of 3. This is an x-intercept of -2. And this one here is an x-intercept of 0. Okay, because it's the bracket x minus 0, having just an x out front. That's different from having a 2 out front. Like, there's a way to make x 0. You just make x 0. There's no way to make -2 mean 0. Okay, some of these are special. This one is squared, so that means it's got a bounce, or a turning point. This one is cubed, so that means a hesitation, or an inflection if you prefer, or a Travolta kind of look, Travolta cubic thing. I mean, it's got a cube there, so of course it behaves like a cubic. Cubic. All right, y-intercept. And people will botch this so often. Sub 0 for x, just like we did before. So y equals 0 times... Now, I wouldn't blame you for just stopping writing stuff right here. 0 times... Oh, who cares what else is there? 0 times anything is 0. So there's our y-intercept. Y-intercept. Okay, let's go and put on some points. -2, +3, and also 0. Okay. And because there was an x-intercept of 0, that means it passes through the origin. Automatically, the y-intercept is 0. We already talked about how you can't have 2 different y-intercepts. So let's see if we can put this together. It starts, or it goes from up to up, essentially. So I'm going down here, and I'm doing a hesitation. So I'm going to make it look like I'm going to turn around. And then at the last minute, I'll do sort of a half parabola in the other direction. Now I have to thread it through 0. So that means it just passes right through. Okay, there's nothing special at that x-intercept. And now I have to bring it round so that it can bounce off at 3. And I find these small little brush strokes really help, even if I were doing this not on the iPad. There's the general look of the graph. We don't know where the max or min are, but hopefully we'll find them next semester in calculus. So one last one to put it all together. We're going to sketch this, but it's not given to us in factored form. We might as well make use of the things it does tell us, though. It tells us that the degree is 3. When it's an expanded form like this, there's your degree. We also know that the leading coefficient is negative. So its basic look is from up to down. We also know from this that the y-intercept is 6. Now you can actually go through the process of subbing 0 in for x, but of course all the terms other than the constant will disappear if we put in 0 for x. So the y-intercept is 6. Oh, we know a lot about this graph already. The other thing we should do here, that we should always be doing when we're factoring, is look for opportunities to factor it easily. Right here, we've got a common factor of -3. Let's take it out. And that makes the whole thing easier to deal with. Instead of having many different factors for 6, now we've only got a pair of them. Or I guess a quartet, because we have to consider plus or minus. And that is the polynomial I'm interested in. Well, let me try and put in 1. I'll get 1 minus 3 minus 2. That's not 0. Let me put in -1. That would be -1 cubed is -1. Minus 3 times -1 would be +3 minus 2. Hey-o, x plus 1 is a factor. And we're just working on getting it into factored form because from the last question we established that factored form helps you to graph. I'm going to do this synthetically. You can do it long division if you prefer, but be really careful about this polynomial right here. What is it missing? It's missing an x squared term, so it needs a placeholder. That 1 is for the x cubed, 0 for the x squared, negative 3 for the x, and minus 2 for the constant. Start to pull them down, multiply and add, multiply and add, multiply and add. Phew, we got a remainder of 0, just like we expected. So we know at this point that the function is actually negative 3, x plus 1, x squared, minus x minus 2. Well, we'll just factor some more then. Magic numbers that add to negative 1 multiplied to negative 2 are minus 2 and positive 1. And we've got a doubled root here, so let's write it that way. X plus 1 all squared by x minus 2. Okay. What we now know is that there are x-intercepts at negative 1 and at 2. And the one at negative 1 is squared, so it's a bounce. Here we go. There are the x-intercepts. It's negative and odd degree, so it goes from up to down. I won't worry about that y-intercept for now. And I know what happens is it bounces off, and then it just goes regularly through. Something like that. Okay. And I'll show that the y-intercept is 6. And that's a pretty good look at the graph. That brings us to the end of this practice assignment. Hope you found this helpful. There is a concept roundup video if you find that there are things in here that are gaps in your knowledge. And good luck with the material, folks. Take care.